All right, let's make a little review here. What's the meaning of the slope of a velocity versus time graph? All right, so let's create a little velocity versus time graph on this page. And let's say that this object traveled from 0, oh my gosh, always label your axes. Velocity is measured in meters per second. Time is measured in seconds. This object traveled for a total of 10 seconds, how about? And it started at 0 meters per second, and it ended with a final velocity of 30 meters per second. Okay, what is the meaning of the slope of this graph? Well, the slope is the rise divided by the run. The rise in this case is the change in velocity. It's the change in velocity. And it equals 30 meters per second. That is the change in velocity on this graph. And the run is the change in time. Equals 10 seconds. Now, that tells us that the slope, the rise divided by the run, is the change in velocity divided by the change in time. And that is the definition of acceleration. There we have it. And we can actually perform that calculation. The slope of this graph is 30 meters per second divided by 10 seconds equals 3 meters per second squared. Now I know I did that fast, so let's do it in a different way that's a little bit better. Let's take the rise, which is 30 meters divided by 1 second. I like to write it out like this. You'll see why. Divided by the run. Rise divided by the run. But instead of dividing by 10 seconds, I'm going to multiply it by 1 over 10 seconds. That is what we call multiplying by the reciprocal. And I do that because it helps me out with these units down here. Because 30 meters times 1 is 30 meters. But 1 second times 10 seconds is actually 10 seconds squared. Now I can reduce this further. 3 meters per second squared. Or we can say that the acceleration, the change in velocity divided by the change in time is 3 meters per second. That's nice. Now, what if I were to ask you, what is the displacement? What's the displacement? How far has this object traveled? Another way to say that is, what's the distance traveled? Now, we know that the area underneath the curve of a velocity versus time graph, that equals the displacement. Now, what's cool is that our units will kind of prove this to us. Our units will show this to us. Okay, so let's find the area of this triangle right here. So remember, the area of a triangle, equals 1/2 times the base times the height. 1/2 times the base times the height. That's the area of a triangle. So, well, let's just do that calculation here. 1/2 times the base. The base is 10 seconds. So the base is 10 seconds over 1 times the height. So the base is 10 seconds. The height is, again, 30 meters per second. 30 meters over 1 second. And so we see here, we have, I didn't multiply the reciprocal of anything. I just did 1/2 times the base times the height. And if we multiply across, we'll notice that our seconds can cancel out. That's great. And we get 300 over 2 meters, which is the same as 150 meters, which is great. That's a distance right there. And that's exactly what we were looking for. We were looking for the distance traveled. And there you have it. Our units canceled, giving us meters. All right, team. That's all for now.